Hello everyone. Today we'll talk about this huge and frightening tool called Gradle that we, as Android developers, daily use. We'll see how to create what we call a Gradle task, a plugin to fit our needs. I am Frédéric, Android developer. I've been working at MWM for 8 years now.
Hi everyone, I'm Cécile, and I'm also working for MWM, but for only a year now. Okay, so what are we really going to talk about today? As Android developers, when we manipulate Gradle files, well, it's usually to do the same things. To configure a plugin, to configure the project, because it's useful, and to configure the dependencies, and of course the repositories to access such dependencies. One of the main issues we have is that we don't like to manipulate Gradle tasks. And when they were all in set, it's fine, but whenever they must evolve, it's definitely another story, and very painful. That's why our goal today is to give you the tools to finally be comfortable when you have to write a custom task, maybe a custom plugin, and most importantly, understand what you do on a daily basis when you use plugins, such as, for example, Android app, which is absolutely a plugin. Quick reminder, though, we know you know this, but Gradle is a build automation tool. It is open source, and it can be used either in Groovy or Kotlin, although Kotlin is now the official language for Gradle.
We'll start by understanding what is a task. A task is a piece of code that performs a unique action, like compiling some classes, creating a jar, or just printing a string. First, we'll see the code of a simple task. Simple because it doesn't take any parameters. It does a unique action, a pre-configured action that can be configured. The code you are seeing can be put in a build.gradle.kts file of a Gradle module. In this file, you have access to the task variable that allows us to manage a set of tasks for this module. And one of the methods you can call on task is the register method that allows us to create a new one. With register method, there is one parameter that is the name we will give to our task. A beginner mistake is to think that the task body is executed when the task is executed. But here, the first println will be displayed at the configuration step. For instance, when you synchronize a project, Gradle have a dedicated lifecycle, and one of the steps is the configuration step. So here, the first println will be displayed, whereas you don't execute your task. If you want to write some code that will be executed at the task execution, you have to put it in a do last or do first block. Like I said, you can put your task code in a build.gradle.kts file of a Gradle module. And that's it. You have no more configuration to do. But in this case, the task is only available to the module you have in the module where the code is. Not outside, not in other module of your project. To avoid this limitation, you can put your task code in the build source directory. Like that, all your modules have access to your task, and moreover, it's a good practice to separate your task code from where it's used. A big disadvantage is that by using the build source directory, when you modify your code, you add new code in this directory, the build cache of all your modules of your project are invalidated. So the next time you build your project, it will take more time. The third solution is by putting your task code in the standalone module. Cécile will talk about this solution later. With this solution, you don't have the disadvantage of a build source directory. And moreover, it's easier with this solution to release the generated jar containing your task code, to release it on a repository in order to use it in other projects. You don't want to keep your task just for one project. Maybe you want to use it elsewhere. With this solution, it's a little bit longer to set up everything. So according to your needs, it may be overkill, and it may be better to use the two previous solutions. Now, let's see how to create a more complex task. Over the course of this presentation, we'll imagine that we'll develop a task that for an Android app module will copy 3 files, the release APK, release bundle, and mapping file, and put them in a new directory that we'll name according our Android app version. Here, 1.0.0, and you can find the 3 files. During this presentation, we'll stay focused on the Gradle part and not on the file management copy. That's why I said we imagine we'll develop that. But this file management logic is just a bunch of call to a file.mkdirs and file copy, no more. We'll put our task code in the build source directory because we want to write Kotlin code and we need to access to the Gradle API to create task and plugin. We'll use the plugin Kotlin DSL that will configure everything for us. It will add all the dependency we need. Because we want to write Kotlin code, we have to add the Maven central repository that hosts the Kotlin library. Here you can see the code of our custom task. There are a lot of new notions that we'll define one by one. First, we'll put our task code in a class. Here, name bundle release file task. This task has to extend the default task to be considered as a task, nothing more. In this class, we define one method, whatever the name it has, and we add to this method an annotation, task action, to tell Gradle that it's this method it has to call when we want to execute our task. There are 3 parameters for our specific example. Here, project dir will contain the path to the Android app directory because we want to get access to the build directory that contains the 3 files we are interested in, the APK, bundle, and mapping file. App version will contain the value of the Android app version, just to name our generated directory. And output directory will contain the path where we want to put the new directory. The 3 parameters are not strings or file. They are here properties. A property allows to delay the computation of the parameter's value. For instance, if app version is computed from the output of another task, by using property, this other task will be executed only when our task is executed. So if we don't execute our task, the other task won't be executed. With property, we do things only when it's needed. We don't do work when we don't need that. And this principle allows us to take less time to execute something when we have to execute it. On each parameters, we add an annotation, input directory, and here output directory. And like that, Gradle knows which parameters will have an impact on the task output. For instance, if you execute your task several times, after the first execution, if input and output directory don't change, the task output won't change. The result should be the same. So Gradle is smart enough to detect that there are no difference in the input and output parameters, and it will skip the task execution. When you execute a lot of tasks, it's a good thing to skip and to skip task execution in order to take less time to the global execution. This principle is called incremental build, and when you see a task with the state up to date, it means that the task execution has been skipped. Now that we have our task code, we have to register it like we did for the simple task. So we go in our Android app module, and we write task.register. We pass the name we want to give to our task, and this time we pass the class containing our task code. And we define the 3 parameters. Because they are property, we have to call a set method on them in order to set values to these properties. And here we pass a naive value just for our example. Now we want to execute our task. So we open a terminal, we type gradle and the name of our task, that is here, bundle release file. We execute it here, and we see that it takes 2 seconds. If we re-execute our task, this time the task state is up to date, and we see that the task, the whole execution takes less time.
All right, so now let's imagine we have a functioning task. But, as Fred said, to execute the task, we have to have an input, which are the APK, the bundle, and the mapping. So we need the app-symbol release task. Let's imagine we need that, and let's imagine that we have written this task, and we want to duplicate it in another project, because this is really a cool task. We don't want to copy-paste it every time, and we don't want to know as a client that we depend on a specific task. In this sample, there is only one, but what about 20, 30, 100? Let's be crazy. Anyway, that's why we're going to go to the plugin solution. Why is that? Plugin encapsulates an infinite number of tasks, and you have to describe definitely in the plugin the order of such tasks. So when you're a client of such plugin, all you have to do is call the DSL and execute the tasks that are registered inside, and that's it. It's really better than duplicating everything. Okay, so we're going to start from the task that Fred just created and go to the plugin. As you can see, we have to create an implementation of the plugin project. This is all in the Gradle APIs. This way, we have to override the apply method, and in this method, there is the target project parameter. In this case, a project is like a Gradle project. So a Gradle project is a Gradle module, for example. So it can be either in the same project or completely something different. The same way that we registered the task from before, we're going to register it to the tasks of the target project with the same solution, with the custom task, the custom class, and its name. We're also going to provide some more information, such as the group the task is part of. It can be very useful if you want to use multiple tasks in the same group. And of course, if you want the description for documentation purposes. Okay, so now let's create our DSL. Keep in mind, we had 3 parameters in the task. When you have 2 here, it's normal, don't worry. We're going to use an extension, which is part of the Gradle vocabulary. We didn't invent anything. And just define it. Okay, this is going to be the input for our parameters. As you can see, we still use properties, just like before, so we don't have to put direct strings, etc., especially if our parameters depend on the result of another task. We don't really know what they are yet. Yes, sorry. To complete the use of our DSL, we have to give it a name. So that's the string we're going to provide, and we're going to use also the extension that we just defined. And this way we declare it from, when we use it as a client, we use it in the Gradle project, the Gradle module. So it's going to start from the target project. This way we get the extension, and as you can see, all we have to do now is do the simple mapping, which is to provide the task with the different parameters. As you can see, we still have 3 parameters. Why is that? Because the first one, the project day parameter, was already gettable from the target, and so we don't have to define an extra parameter. It's just easier this way. Okay, so now the plugin works, the Kotlin part anyway. But to make it available to other modules of our project, our Android project, we have to expose it. To do such a thing, we're going to use the plugin provided directly from Gradle, which is Java Gradle plugin, and use its DSL to give it a name, and of course, the task is going to be represented by. No, just switch. Okay. Finally, when you have done a Gradle sync, you have exposed your plugin, and when you're back in your app module, in the Gradle file of the app module, you can just use the plugin we defined with its ID we just created, and as you can see after a Gradle sync, the DSL is available. Okay, for best practice, separation of concerns, etc., it's best to keep the plugin from a separated directory, so you don't mix it up with really the core of your project. But as you can see, this is still a dedicated module. Don't be fooled by the correlation. I'm going right there in a few seconds. Thank you. As you can see, this still looks like a Gradle module. It still has a source folder, it still has a build.gradle like KTS file, and it can also have tests. In this case, it doesn't because, well, it's just a sample, but you get the point. As I said before, this looks like a Gradle module, but it's not yet. What you have to do the trick is add in the roots file of settings.gradle like KTS the include build of the folder of your plugin. This way, after a Gradle sync, the content of your folder will be available, just like a library, to the rest of your project. And as you can see, I'm not lying, promise, this is a real screenshot. The task name that I define in the plugin is available, in the group My Plugin, and most importantly, in the app module. Okay, so we have a plugin, but for now we're still stuck in the same project. Maybe we want to reuse this plugin in a completely other project, personal, another app. Anyway, you have, if that's the case, you have to publish it. So you have to use the we use at MWN to use the Maven publish plugin, but there are many others, and you can publish to Maven local, we see, Maven central, Gradle portal plugin, you pick, or even your custom repository if you have an in-house repo. Anyway, what matters really is that in the DSR, all you have to do is provide the name, the complete name of your plugin, which is the group, the artifact ID, and the version. After a Gradle sync, all you have to do now is to publish it. That's why we like Maven publish. It's because we can publish it to Maven local, and so test locally that everything was fine. But if you want to publish it for real, you can directly go to Gradle publish, and that would do the trick.
And that's it for us, for our 20-minute talk. During this presentation, we learned a lot of new notions that are at the core of the Gradle task and plugin development. And like I said, in only 20 minutes. It's really easy, finally, to learn everything, to develop, and to fit your needs. You don't really need more knowledge. So since right now, Gradle shouldn't be this incomprehensible tool we are afraid of. There are still a lot of subjects to talk about to improve our task and our plugin to make it easier to use for ourselves and for our client. Maybe we want that our task, we want to execute only one task to generate the 3 release files, APK, release APK, release bundle, and mapping file, and put them in our custom directory. To do that, we can make our task depend on assemble release and bundle release. To other improvement will be to set default values for some of our task and plugin parameters. For instance, the output directory, maybe we want to set the default value build/output because we know that our clients won't need to override this value often, so we set a default value and it fits 99% of our clients. To do that, we have to call what Gradle calls a convention. Third improvement is to hide the fact that we use property and that we have to call the set method of the property to our client. It's not obvious that we have to call this method, so maybe we can replace that in our custom DSL by calling maybe a function. So we could change that. And so finally, Gradle is not this horrible monster we thought it was, and we can make it our friend to fit our needs. So don't hesitate to create your own task and plugin because it can be very useful and it can help you, us, everyone in our daily life of developers. Thank you very much for watching this presentation. So if you have any question, it's the moment. And if you want to talk about this presentation or Gradle in general, MWM has a stand, so come to see us.
No question. Thank you for your attention.